Hello everyone. In this video, we are going to see another problem in power electronics. The problem is, in the following chopper, the duty ratio of the switch is 0.4. If the inductor and the capacitor are sufficiently large to ensure continuous inductor current and ripple-free capacitor voltage, the charging current in amperes of the 5-volt battery and a steady state is dash. So here the circuit is given, and it is from the circuit it is clear that the converter or the chopper is the step down chopper, and it is given that we have a duty ratio of 0.4, and capacitor and the inductor are large enough so that we get the continuous inductor current and ripple-free capacitor voltage. We need to find out the charging current in ampere and the charging current of the battery, 5-volt battery, and a steady state we need to find out. And we know that for a step-down chopper, the output voltage is given by duty cycle into the supply voltage. So alpha into Vs. Our Vs is given as 20 volts. And it is given that the voltage across the load, which is nothing but, here the load is nothing but the 5-volt battery and resistive load. A 5-volt battery with its internal resistance is given as the load. So for this case, we can write V0 in terms of the battery voltage and the drop across the resistance 3 ohms as V0 is equal to I0 R plus E. And so we can find I0 as V0 minus E divided by R. And substituting for V0 as alpha into Vs, we get I0 equal to alpha Vs minus E divided by R. Alpha is given as 0.4 and Vs is given as 20 volt. So 0.4 into 20 minus 5 divided by 3, which is nothing but 1 ampere. So the charging current is 1 ampere, which is the required answer. Now we will see one more problem. Figure 1 shows the circuit diagram of a chopper. The switch is in the circuit. In figure 1 is switched such that the voltage Vd across the diode has the waveform as shown in the figure 2. The capacitance C is large so that the voltage across it is constant. If the switch is and the diode are ideal, the peak-to-peak ripple in ampere in the inductor current is dash. So we need to find out the peak-to-peak ripple current of the inductor. It is given that the capacitance is so large so that voltage across the capacitor is constant. And this is the circuit given. From the circuit, it is clearly known that the circuit is a buck converter or buck chopper or step down chopper. And the second waveform shows the diode voltage. We know that for buck converter, V0 equal to Vs into T on by T. Vs is given as 100 volts and T on. So T on is nothing but during the period of T, during the period T on, we have the diode which will be in the off condition. So diode voltage will be at the supply voltage. So we can take that the T on is nothing but 0.05. So 0.05 T on is 0.05 into 10 power 10 power minus 3 divided by the total time period is 0.1 into 10 power minus 3. So it is given that it is given. So we can take T on as 0.05 into 10 power minus 3, and we can take the total time period as 0.1 into 10 power minus 3. So we can obtain V naught as 100 into 0.05 into 10 power minus 3 divided by 0.1 into 10 power minus 3, which is equal to 50 volts. The peak-to-peak ripple current of the inductor is given for a buck converter. It is given as del I equal to V naught T off by L. Substituting V naught T off and the value of L, which is given as 1 millihenry, we get the ripple current as 2.5 ampere, which is the required answer. Thank you.